Hello everyone, welcome to Spectra Education and myself Dr. Rajesh Sarpanja, and we are discussing about the mathematical physics, which is core course 1 for B.Sc physics students. Right. Today's topic is curl of a vector field. Here we will discuss about the physical meaning or geometrical meaning of the curl of the vector field, and number 2 we'll discuss about the steps to solve the numerical problems. Right. So first we'll discuss about the physical meaning of the curl. Basically, curl of a vector field is related to the rotation or rotational tendency of the vector field. What it means? It means that if we consider a two-dimensional vector field, let's say this is a space, and which is basically two-dimensional space, and at each and every point, if we consider several points here, and if each and every point represent a vector, for example, let's say each and every point represent the force vector. So if we consider these points where each and every point representing the force vectors, so then this two-dimensional space becomes a force field, right? So in this force field, if we consider any point, for example, let's say this point A, at that point or around this point, if there is a rotation of these vectors, then we can say there is a curl of the vector field. Okay, so curl basically related to the infinitesimal rotation or rotational tendency or the rotation of the vector field. So why this term curl is related to the rotation of the vector field? Because if you just think about the curly here, you all know that the curly here means is just like a spiral type or coil type, right? So that means there is a tendency of rotation of the physical entity. So this curl term basically it comes from the curly term. Okay, so that's why this curl is associated with the vector field. That means it is related to the rotation of that vector field, or in other words we can say it is the measure or it is the measurement of the rotation of a vector field at a particular point. Why I have written at a particular point? Because just like the gradient, we have discussed about the gradient divergence, where we have considered the vector field, but the gradient is always associated for a particular point. Divergence is always associated for a particular point. Similarly, the curl is also applicable for a particular point. If I consider this whole vector field, force field, at point A, there may be the rotation of the vector fields, but if I consider any other point, for example point B, there is no rotation of the vector field, then at the point B there will be no curl of the vector field. Okay, so curl is a point dependent quantity also. So what is the mathematical symbol or how to find out the curl of the vector field, we will discuss here. So the mathematical representation representation of curl. Curl means curl of a vector field. Okay, just recall that the gradient means when nabla is associated with any scalar function, let's say phi. it is known as the gradient, right? What was the divergence? Divergence was defined mathematically when nabla is associated with any vector field V, let's say with the dot product, then this is divergence. So the curl, similarly curl is represented as when the nabla vector is crossed with the vector field. Here let's say the vector field is the force field, which is F. So this is known as the curl of a vector field F, right? Here F is the vector field. Here one interesting thing is that why the cross product is chosen to represent the curl of the vector field, because the cross of the two vector itself gives an idea about the rotation. For example, if we consider a vector and another vector b vector, let's say this is a vector and this is the b vector. So what will be a cross b? A vector cross b vector, that means if you take the screw, or if you take your right hand thumb rule, so if you just rotate a vector along this b vector, it gives you a vector cross b vector which is perpendicular to both b vector and a vector. So a cross b itself gives an idea about the rotation of the vectors. So that's why to represent the curl of the vector field, this cross product is in between the nabla and the force field. So this is the mathematical representation of the curl. Now let's take an example of the vector field. For example, this is a vector field. That means at each and every point we are considering several regions. Although each and every point representing a vector, but here I will show only few vectors. Let's say this is just at the region A, and at a different region B, this region V, the vectors are like that. So in the region A, there is no rotation of these vectors, right? So that means here we can say no curl. We can say no curl. No curl means these vectors, or we can say at that point A, the vector field F is irrotational. What is irrotational? So if anyhow through mathematical calculation, if we get that curl of this vector field is 0, it gives a 0, then we can say this vector field for a particular point, obviously for a particular point, this vector field is irrotational vector field. But if we consider the point V, we can easily observe that these vector fields are, or vectors are rotating. So at that point we obviously get a value for this cross product, and since this is a cross product, so we can say curl of a vector field is a vector. If we compare with the divergence, divergence was a dot product between nabla and the vector field. Since it is a dot product, so it gives you a scalar function. Okay. And what about the gradient? Gradient, here this is a vector differential operator, it is a scalar function, but the gradient itself is a vector quantity. Okay. So this is the basic difference among the gradient, divergence and the curl. So now let's try to find out how to solve, because we cannot see through our eyes or any instrument that is there any rotation of this vector field or not, but through the mathematical calculation of the curl we can find out is there any rotation of that vector field for a particular point or not. Okay. So what are the steps to calculate the curl of a vector field, we will learn right now. So the steps to calculate the curl of a vector field. So here we can write the steps to calculate the curl of a vector field. Okay. So first steps is that for let's take an example. Let's take an example. A vector field, let's say force field is given. It is just like that. It is xy I cap plus yz j cap plus zx k cap. Okay, and it is asked that for a particular point, let's say at the point 111, what is the curl of this vector field? What is the curl of this vector field? So what is the point 111 in Cartesian coordinate system? If it is x, if it is y, and if it is z. So as we know that first you have to move 1 unit along this x-axis, then take positive 1 unit along the y-axis, and take positive 1 unit along the z-axis. If you get this point, let's say this point phi, which is 1, 1, and 1 point. So at that point, if this field is fully covered with force vectors, so at that point phi, we want to know is there any rotation or not for that vector field. Okay, so step 1, first write down the expression for nabla. So nabla is basically I cap del del x plus j cap del del y plus k cap del del z. Second step is that write once again the given function. So f is xy I cap plus yz j cap plus zx k cap, and in the third step you have to perform this cross product. Here we will use the algebraical form of the cross product. Cross product, what is the algebraical form of the cross product? Let's say for a vector cross b vector, the algebraical form is the determinant, right? The first row is the unit vectors I, j, k, and the second, let the component of the a vector is ax, ay, az, and component of the b vector is bx, by, and bz. Then if you solve this determinant, you will get the a cross b. So similarly here we will use this determinant. The first row will be the unit vectors I cap, j cap, and k cap, and the second row will be the component of nabla vector along the I cap, j cap, and k cap. So the second row will be del del x, del del y, and del del z. And what will be the third row? Third row will be the component of a vector along I, j, and k. So it will be xy, it is yz, and it is zx. So then you have to solve this determinant. Then at the fourth point, you have to find out this curl of f at the given point 1, 1, and 1. That means then you have to insert x is equal to 1, y is equal to 1, and z is equal to 1. So now let's calculate this determinant. Okay, let's take one page here. So I am taking one page. So what was the determinant? Curl of a vector, and it was I, j, k. It is very easy. Del del x, del del y, and del del z. It was xy, yz, and zx. So solve that one. So first I will take this I cap. That means I will cancel this row and this column. So okay, so I will consider, then if we consider this cross multiplication, so del del y of zx minus del del z of yz. So this is the first term. Then I will consider the second term, where I will take the j cap, but I am using this plus sign. Okay, so I believe that you all know how to evaluate this determinant. If you have any problem, then let me know. I will show you how to solve the determinant problem. So if we take this j cap and here is the plus symbol, so then I have to take from the right side. So it will be del del z of xy minus del del x of zx. But if you here use this minus symbol, so then inside the bracket it will be alternative. Okay, plus k cap. So now I am taking this k cap. So this row and this column will be cancelled. Again from the left side, so it is del del x yz minus del del y xy. Can solve it. This is the partial differentiation. So I cap as it is. Now it is del del y. It is the partial differentiation. It will act only on the y term. But if it is performed on the any other term like the z and x, it gives you the 0, because for this partial differentiation del del y, this zx is behave like a constant. Okay, so the first term is 0. Here del del z, but there is a z term. So del del z will operate directly on the z, and del del z of z gives you z, and y remains constant. So it gives you y into 1, right? So similarly for the j cap term, del del z is here, but there is no z term. So when it will operates on this term, it gives you 0. So takes it 0, minus it is del del x. So del del x will operate on the x, z remains as it is. So z into del del x of x is 1 plus k cap. You will get k cap means it is del del x. There is no x term, so it gives you 0. So it is 0 minus this is del del y. So it operates on the y and gives you 1. X remains as it is. So x into 1 you will find. So it's basically minus y I cap or minus z j cap minus x k cap. So if I take minus common, so it will z j cap will say plus and plus x k cap. So this is curl of f, but you have to find out curl of f at the point 1, 1 and 1. So we will use here y is equal to 1, z is equal to 1 and x is equal to 1. So it gives basically minus I cap plus j cap plus k cap. So at that point 111, this is not equal to 0. There is a value, although it is a negative value. Negative value basically we can think there is a clockwise rotation for negative. For positive, if it is positive, then we can think it is anti-clockwise. It depends on you. But here the one thing is that it is not 0. That means at the point phi, if we think the previous page, you will find, okay, here I think this point phi, what we have found out? We have found out curl of f becomes minus of I cap plus j cap plus k cap. So there is a obviously rotation around this point in this vector field. Okay, so these are the 4 steps to solve any problem regarding the vector fields. So that's all for the day. In the next few lectures, I will just I said in the previous video, I will discuss different types of problems regarding gradient, divergence and curl from different university exams, different competitive exams, and with this discussion I believe that we will be able to solve any problem regarding divergence, gradient and curl. So that's all for that moment. Bye bye, see you again.